Alright guys, in this one we're going to be looking at multi-step energy diagrams. Okay, so that's when we're taking reaction mechanisms, giving them their energy diagrams. We're going to be drawing those peaks. Remember, the basic look of an energy diagram is something like this or something like this. And that depends if it's endothermic or exothermic. And we're going to cover all of that. We're going to look at two short answer questions. So here we've got an overall reaction, and we have the two steps for them. We have NO2 and F2 producing NO2F as represented above. Proposed mechanism for the reaction has two elementary steps as shown below. So we've got two steps, one's slow, one's fast. Okay, other important information we need to know that overall the delta H is negative. Remember, delta H is enthalpy, and if it's negative, it's exothermic. And if it's positive, it's endothermic. Okay, if it's exothermic, the overall curve should go under the starting point. So here's the starting point, here's the end point for an exothermic. And for an endothermic, the starting point will be lower than the starting or the end point for an endothermic. And that's because an exothermic energy is being released, and an endothermic, the energy is being absorbed. And we denote that with a negative and positive sign on the enthalpies. So to draw this reaction or this reaction diagram, we're going to get a curve. And there's 2 points that we need to make sure we do for this one. We need to make sure the relative activation energies of the two steps, and we got to make sure the enthalpy change for the overall reaction. So I'm going to start with the overall starting and end point, because I feel that's a helpful way to get where I need to go in between. And the delta H is negative. Okay, that means it is exothermic, which means it is going to end up lower. So I'm going to draw a line right here. And I could write the overall reaction product since they did NO2F, NO2F. This is not necessary. We only need to make sure we have these 2 points, but kind of doing it just so we kind of understand where I'm getting that. Here's our reactants and our products, and we're trying to get there in between. Okay, and I did it lower because it's negative. So I've already accomplished this one, the enthalpy change for the overall reaction. Now I just got to make two curves that help get from point A to point B, or from the starting to the ending point. Okay, now step one, we don't know if it's positive or negative delta H, so we don't know where it ends up, higher or lower, but we do know it's a slow step. And if it's a slow step, it's going to have a bigger peak than a fast step. So that's really the only difference, and that's what I need to make sure I do for this this bullet point, is make sure my first peak is going to be a little bit bigger than the second peak. So this is totally fine. It doesn't tell me exactly, and it's not like the greatest drawing, I could do it a little better, but it doesn't tell me exactly where the starting and end point for the first one should be, but I do know that overall it needs to end up down here. So this is a totally plausible reaction pathway. If I wanted to draw it a different way, I could. The one important thing is I make sure that this peak is bigger than the second peak. You see, both these are totally fine because I made the first peak bigger than the second peak, and it overall ends lower. So this could be a very good reaction pathway and energy diagram for this reaction. Okay, going to do the same exact thing for this one. In this case, though, I'm giving a little bit more information. The first step is fast, and so I'm going to do peak 1 and peak 2 right here. It's fast, so it should have a smaller peak, and it is endothermic, so the reactants are higher up than the, it's endothermic, so the product's energy is going to end up higher than the reactants. In peak 2, it should be the bigger peak, and it is exothermic. It's got a delta H that is smaller than 1, so it's negative, making it exothermic. I also got to know with the overall whoops, I can't type today. The delta H is negative, so it is also exothermic overall. So I got to make sure I do all these main points when I do my drawing. Luckily, they give it to you here, so that's kind of nice that the products overall should be lower than reactants. If they didn't give it to us, we've got to make sure that we have that in there. Peak 1 has to be smaller and endothermic. So we can do something that's smaller, but it ends up right here. It's endothermic, so that works. And then the next one has to be exothermic. And a bigger peak, so I'll give it a bigger peak and drop it down here. So this fits. This would give me all the points that I need for this question. Peak 1 fits, it's smaller and is endothermic. Peak 2 is bigger and it is exothermic. And the overall reaction is exothermic. So on all counts, we are good for this reaction. So these are kind of like the questions that you could probably see. The other thing is multiple choice questions. They give you a couple plausible diagrams, or they might give you a reaction mechanism that you have to select, match the graph to the, or the diagram to the reaction. So hopefully that was helpful.